Hello and welcome to this film, which is all about chromatography. Now in this course we're going to be looking at three different kinds of chromatography in a little bit more detail, but in this film we're going to look at how chromatography works in general, and in particular how intermolecular forces that form between the components in a mixture and the mobile and stationary phases will actually allow us to separate the components of a mixture when we carry out chromatography. Okay, so first of all, let's remind ourselves of what chromatography is. I say remind ourselves because there's a good chance you'll have done a simple chromatography experiment before by the time you get to year 11. And chromatography, to cut a long story short, is a way of separating mixtures. It sometimes doesn't work, especially when you do it in a very simple way, like getting the pigments in a dye to move up a filter paper. But what you may remember when you did it the first time is that you may have been told it basically depends on how soluble the different parts of the mixture are in the solvent that's moving along the filter paper. And there's some truth in that for sure, but what we're going to do in this film hopefully is explore that in a little bit more detail and come up with some key terms that will help us explain. Okay, so first of all we're going to look at something called the stationary phase. Now all the pictures that you see in this film are of simple chromatography experiments like the kinds of chromatography that you're likely to have carried out yourself. Okay, so filter papers used as your stationary phase and water often used as your mobile phase. So in general, not just in these simple experiments, but in general, in chromatography the stationary phase is the part that doesn't go anywhere. Okay, so to give you an example, if you were using a filter paper and you had some dots of ink on it that you wanted to separate from the dyes in, you wanted to separate the dyes in those inks from one another, I should say. So in that case, the filter paper would be the stationary phase because it's not going anywhere. Okay, now if we compare that to what we mean by a mobile phase, so you might remember that if you dip a filter paper in water, whether or not it's got an ink on it, the water will start to rise up the filter paper. So the filter paper is kind of staying where it is, it's stationary, and the water rises up it moves. So in the case of this simple chromatography experiment that we keep referring to, the water is the mobile phase because it's moving. And the mobile phase will usually take parts of a mixture with it. And what we observe is that some parts of the mixture move further than others. Okay? Now, if we try and explain why that is, what we've got to do is to consider what forces are formed between the parts of the mixture itself and the stationary phase and the mobile phase. Okay, so if we've got an ink spot that we want to separate, and we're going to separate it out into these dyes, then as this solvent, the mobile phase, moves up the stationary phase, the distance that these different colours are going to move is going to depend on how strong the forces are between these 5 different colours and the solvent, and how strong the forces are between them and the stationary phase. Because the more time they spend attached to the stationary phase, the less they're going to move, and the more time they spend attached to the mobile phase, the more they're going to move. Okay, so if we can consider what kind of intermolecular forces will form between one of the parts of our mixture and the solvent, or one of the parts of the mixture and our stationary phase, then we can get some idea of whether we think it's going to be good at dissolving in the mobile phase or sticking to the stationary phase. And there's some key terms we use for those things, so the dissolving and the sticking, and they are adsorption and desorption. So if I can just risk a little bit of drawing here. Okay, already it's gone not particularly well. That was supposed to be quite a vertical line. But here is a stationary phase, so like our filter paper. And we might have some water coming past it on its way up. Okay, on its way up the filter paper in our simple experiment. So here's our mobile phase out here, and here's our stationary phase. Now, as I say, these things can take lots of different forms. Okay, they don't have to be filter paper and water, but for the purposes of this, just trying to take it back to the simple things we know. Let's imagine this is a filter paper and this is some water. Now, if I had a molecule that formed very strong intermolecular forces with water and very weak forces with the stationary phase, then the likelihood of it adsorbing onto the stationary phase would be quite small. Adsorption is the process of any component in this mixture that's being carried along by the mobile phase of actually sticking on to the stationary phase. So when a particle in the mixture forms intermolecular forces with the stationary phase and bonds with it, that's called adsorption. Now, that needn't be a permanent thing. In fact, most times it's not. Okay, so if I've got a particle that has adsorbed onto this surface, then if it desorbed, that would mean that it's fallen off it. So in other words, the forces that it formed with the stationary phase weren't so strong that they kept it there forever, and at some later point in time it might get back into the mobile phase. Now, depending on how often it adsorbs and how often it desorbs, that's going to influence how much time it spends in the mobile phase, in other words, how far it travels when we carry out our chromatography. Okay, so in general terms, that's what intermolecular forces have got to do with chromatography. And really and truly, in this topic of chromatography, that's what you've got to understand most of all, that there are things called mobile and stationary phases, and that the intermolecular forces that form between these things and the components of a mixture will influence how long the components of the mixture stay on each one of these things and how far they travel and how well they can be separated. Okay, we're now going to look at a few different types of chromatography where we're going to look at these phases in a little bit more detail, but really and truly that is the bulk of the topic. Now, hopefully it makes sense. If it doesn't, or if you've got any questions or if you've got any comments, then please feel free to come and see me and ask some questions or post a comment on YouTube.